Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So this morning we have Ryan White here, who got his PhD from University of Glasgow, and his thesis weighs about 2.5 pounds, I think, maybe a little bit more. And he's a postdoc now at University of Maryland, and he's going to talk about some of the stuff he's done in his dissertation and since.
Okay, good, thanks. I came here to give a talk in 2003. It was Sue that was my host. And I think it was in this same space, this exact same room I gave my talk in. And I started to speak, and the first thing that everyone said was microphone, microphone, microphone. Right. So if you can't hear what I say, just say so, and I'll try to speak a little bit louder. Okay, so I'm going to talk this morning about work that I did for my PhD. I got my PhD back in 2004. So you're probably thinking to yourselves, what have you been doing for the past year? If you're not going to talk about this, what I'll do is I'll use the main part of this talk, to discuss my PhD work, and then I'll come back at the end of the talk to discuss the cool, interesting things that I'm doing now and ideas that I've got for the future as well. So I've been told that this cool little gadget here will let me stand here and yet flip pages, and it works. Okay, cool. So what I'm going to talk about this morning is implicit feedback. I'm going to start off by, on the way here, I was thinking that I had put this thing in my title, implicit feedback techniques for deployment and evaluation. But I didn't actually have, as part of my talk, any description of what implicit feedback actually was. So I sat on the aircraft away here, and I was thinking to myself, what is implicit feedback? So I came up with this as it's a bit of a hack, but I think it goes at least part of the way to capturing what implicit feedback is. Basically, it's trying to make inferences about intentions from interaction. Okay, so you've got a person interacting with your interface, your system, and based on their interaction, you try to infer what they're interested in. What I'm going to talk about this morning are three main aspects of this. The first one is, it tells me it's got a laser here. The first one is how do you make an implicit feedback interface? What an implicit feedback model should. So after you pick your interface, what implicit feedback model, if you've got a lot of different choices, what model do you pick to apply to your interface? And then after you have that, after you have your interface and you have a model picked, how do you let users control the feedback at the interface? So how do you let them control the feedback, the input of the feedback, and also how the feedback's used as well? So that's going to be the three parts of my talk this morning. So I do the second part, what implicit feedback model to use, using simulations. of searchers. And I do the third part, how should interface support for implicit feedback be offered by real user evaluations. So that's, I thought to myself, this is an outline. What can I call this slide? And the best I could come up with was overview, right? So what I'll do is start off with a bit about me, my background, where I got my PhD and such like. Talk about what I've been doing. So those three parts that I had on the previous slide. My thoughts for the future and an opportunity to ask me lots of questions at the end as well. I saw that I had an hour and a half for this talk. I won't talk for an hour and a half, so you can sit back and relax and don't think, oh no, I've got to listen to him for a long time. I'll probably talk until about 11:30, and that will give us half an hour for questions or discussion afterwards if that's appropriate. Okay, and also I put this here as well at the bottom. I think I'll use a different pointer because that's not really clear. Okay, so I put down here at the bottom lots of me's and my's. When I was typing this out, I went back and I looked at a bit about me, a bit about my research, my thoughts of the future. Ask me. So hopefully this talk is of some use to you. Okay, so I did my PhD in Department of Computer Science, University of Glasgow in UK. I mainly focused on interactive information retrieval. I won this year's BCS award for the best PhD in the UK in CS. And I'm currently a postdoc. This is really like the fancy name for postdoc. At the Institute for Advanced Computer Studies, University of Maryland. You can all read, so that's what that says. So that's a bit about me. Suppose you're probably thinking to yourself, why does he do this work? What makes him wake up at 2 a.m. in a cold sweat thinking, I know what's going to solve search? And basically, I want to help people, address problems that they have, hopefully solve those problems. More and more people are using tools like Google and MSN Search and Yahoo and such like to get the information that they need to address these problems. But there's also a problem with how they interact, right? They have short queries. They don't tend to look at the documents properly. They don't tend to explore the information that IR system gives them back. They don't tend to use things like more like this that can be of use, but they don't seem to want to use. So I'm interested in this space here, working in techniques to help address all of these problems. So I didn't just pick one, I picked all. Okay, so what I did during my PhD, I came up with techniques to help people engage in online search, come up with what I call content-rich interfaces. I'll come back to them in a second, in a few slides' time, that push information to searchers. Right now, the way that things work, if you're engaged in information retrieval, you have got to go into the document and pull the information out yourself. You get indications about what documents are good, but you then have to go into those documents and say, well, in that document, that's an important part, and you do get a small abstract displayed to you at the in a list of documents you get back, but that's often not of a lot of use. I also came up with different implicit feedback frameworks. I'll talk a bit about them. What they do is they approximate interests So you would say, okay, at this point in time, the person's interested in this thing. And they also approximate how much an interest changes over time. So if you start off looking for information on sports, and then you go to look for information on, I don't know, cars or movies or whatever else, then that's an interest change. And I have ways to handle that I'll come back to later on. I also used user simulations as well to test out interfaces and test out interfaces and implicit feedback models as well. And I did 5 user evaluations. I'm only going to talk about one of those 5 this morning. Okay, so part 1. So going back to my first slide, this talk's going to be in 3 parts. Okay, the first part is how do you make an interface that would let you gather implicit feedback. So I put in the query implicit relevance feedback papers, implicit relevance feedback in quotes, and into MSN search. And I was quite, this is a paper that I wrote, and I was quite near the top of the list, so I was quite pleased about that. I picked that especially because I was near the top of the list, I have to admit. Right, I tried lots of different, lots of different terms and combinations, and I wasn't, I was, perhaps in the top 10, top 20, something like that. But, I wanted to get one query where I was top so that I could show this bar and also these things here as well. So eventually, after some trial and error, I got to this query. Okay, so say you have an interface that looks like this. Okay, what would count as implicit feedback here? Well, what you would tend to see is if you took the mouse pointer and you clicked there, then that's an indication of interest in that document there. Or you could say it's indication of interest in the words that appear in the title. Or you could say it's interest in the title and the abstract. But that's basically, as far as you can go with this. You can perhaps say, well, they interact with that document and that one and that one. That gives us a better picture. But what I wanted to do was to make an interface that could be used to capture implicit feedback. So, what I wanted to do was try to make users interact more than just this click and jumping to a document or whatever. So this brought me to the idea of content-rich interfaces. Now, this is a move away from documents towards information. Okay, people approach an information retrieval system with an information need. It's not a document need. It's only in a few occasions where the person's after a particular homepage, or they're after a particular fact that's on a homepage or something like that. But they tend to be after information. So I basically went from a technique to a way to help people explore their documents better, to a move away from document by document towards these things called top ranking sentences. And what these are, they're query relevant sentences that have been extracted from the top ranked documents, ranked completely independent of source document. So you have at the top of a list, I think the next slide has a description on how we make these. So say we assume the top 30 documents here. We start off with this web document in this case. It's got some sort of this document contains sentences, and those sentences appear in a particular order. So this is the document order. You then extract the sentences and you score them. Now you score them based on the query terms, or query terms plus words that co-occur with the title, or query terms plus any words that have particular formatting, or things like this. And you can obtain a score order. So you have a document order and you have a score order as well. Now what we do is we take the top 4 of these sentences, so in this case 1, 5, 4, and 3, and compose a document summary from that. So you go from here to here, right? So that's your input and that's your output. Now each of these, just I'll take a drink, but each of these sentences here has got a score. And what we do is we take these 4 sentences from the top 30 documents up there, and we put it into a big ranked list. Now that is a ranked list of sentences scored completely independent of document. So you've got you've got your sentences here that are grouped by document. You also have a completely different thing, which would be 4 times 30, 120 sentences, ranked based on their score, not ranked based on where they come from. So, I basically see that at the bottom there. Okay, so to come back to this, I put G** because I thought, that's a bit of a bad word at Microsoft these days, but I picked it because it's got a Java API. I don't know if there's any plans afoot to do an API for MSN search, but there's now one for Google, there's one for Yahoo. It may make sense, I'm not sure, but controversial. Okay, so we've got the query goes to Google. We get back the top 30 documents. We extract the content from those documents. So by content, we basically mean sentences. We then score the sentences, and you get back an interface that looks something like this. So I say here, no documents, and that's true. Basically, what you get back, this is a document pop-up that appears when you take your pointer and you put it, on this sentence. Then this document pop-up appears next to it and says, well, this is the document that sentence is from. But when this page first loads, all you have is this thing here, this box, these sentences. You don't have any documents. Yes?
So this seems to work very well for underspecified queries, but for your query that you said, relevance feedback, implicit relevance feedback papers, getting the most relevant sentences from there, I'm not sure I can see how it works, or if I have a navigational search. Also, I don't see how these work. So
these, these tend to work better for a task where the person's got to gather information to help them make a choice, right? Or just gather, background information on a particular thing. If you're interested in a fact, then this is not of a lot of use. If you're interested in a fact, a homepage, or a particular bit of information, then you'd be better off using an interface like that. Okay, so we have this interface here, ranked list of sentences, and you have to actually interact with a sentence to get to this pop-up about which gives more information about the source of that sentence. So you get title, you get URL, and you also get some more sentences out of this list that also appear in pop-up too. Yes?
Are you going to tell us how you weigh the sentences?
Yes.
Okay.
and we'll maybe look at this off, but the question I had is, how different is this than just taking the top end sentence, just taking the summaries, so the snippets, so the first thing that, of the first document, the first thing, the second document?
We compared this. So this, we did a paper on this that got Best Paper at Interact in 2003, and what it did was it compared this interface here, just with this, against the interface it displayed for each of the document titles. So it had title and it had these 4 sentences as well. So we did do a comparison against an interface where you've got a title and a snippet, but in this case the title and snippet were quite long. So we didn't actually do it. In fact, yes, we did do a comparison. Sorry, I'm getting confused. We did actually do a comparison against an interface like this, and to come back to a point I made a couple of seconds ago, if you've got an exact need, then that works better.
But I guess what I'm asking is, you can think of your interface at some level, like an easy way of doing it. We just take this and strip off.
Yeah, so you take off these things and just show.
Moving sentences? Like, are you really finding an awesome sentence in the 30th guy?
Yes.
At the top?
Yes. Yes. So what this will do is, if you've got a sentence here that occurs in a low-ranked document that may be of use, then that will appear near the top of the list. So what you see here is completely independent of documents, completely independent of document ranking. So it's a way to get access to information that might be hidden low down. Yes?
You said that titles tended to be quite long, and I'm surprised that this is working so well. Were these, how were these queries selected? Were these sort of question answering type queries where a particular sentence would be the best thing, or were they?
We would give people tasks, and they would use an interface like this, and then we'd ask them afterwards how the interface performed.
So the tasks were so this 4 specific kinds. So do you think the task, I guess, influenced this? Namely, this was more sort of were these more sort of question answering type tasks where this kind
we tried 3 different task types. A task where they would have to get one piece of information, one fact. A task where they'd have to get information to let them make a choice, and a task where they just had to gather information about a particular topic. So 3 task types, and we controlled them as part of the experiment as well. Okay, so we've got this content-rich interface here. So then from that, I jumped onto this idea of push and pull information retrieval. Okay, pull information retrieval is basically what happens right now. So you're the person as a searcher that's got to go into the document and extract the information that you're interested in. You tend to look at things, you would see a ranked list of documents. You would approach those by going through it document by document. So abstract by abstract, if you like. You would tend to make assessments based on how the document looks from the outside, so how it appears externally as opposed to internally. So that's what I would call pull information seeking, where you're the person that's going into documents and having to extract information. So I'm talking about now after you get the document list back. Okay, so you do your query, you get your list back, then what happens? So right now, you have got to pull information out. You interact in a certain way. And what I was wanting to push for, I suppose, was push information retrieval, where the information extractions, going into documents and extracting the important sentences, was done by the system. You wouldn't look at documents, you would look at sentences. You would interact with the content of the document set, not just some external view of that content. So this is interface 2. So, you know, basically what happens here is the same stuff. You have your query, you have going to Google, get top documents, extract content, you get back interface that looks something like this. So on the right-hand side here, you have your top-ranking sentences. Top-ranking sentence. On the left-hand side, you have your document title. You then have this thing here, which is a 4-sentence summary of this document. So what would happen is you would take your pointer, put the pointer there for 2 seconds in this case, and you would get this pop-up that appears. And then you could see each of these sentences in the context that occurs in the source document as well. So let's skip a little bit. So that's a sentence in the summary, and that's a sentence in the context that occurs in the document too. Now what would happen is every single interaction that you make with an interface, with this interface, was taken as an indication of your interests. So you could start off by saying, hey, that's a good sentence down there. So take the mouse pointer, either click straight on the sentence and jump to the source document, or interact with this arrow here, which would indicate to you where that document was from. So you take the pointer, you click there, and it will say this sentence is from this document. Okay, so you're then, if you want to, you then would go from that sentence, take the pointer, go there to get more information about this document. So what's happening is interface is taking you from step to step. It's saying, okay, that's your start point. What is the next start point? What is the next point in your path? So you can go from there, you know, you could click there, this gets highlighted, go there for 2 seconds, you get this, interact with any sentence, you get that sentence in context, and every single interaction is used as an indication of interest. And you take words from the information that people interact with, and you use it to compose a new query. So to come back to a question about how these things are actually made. Well, titles are obviously made by the document author. The query-based summaries are scored based on the query words that contain, words that co-occur with the document title, words that are formatted where in a document a sentence occurs. Pretty basic stuff. I mean, the aim of this work was not to look into new ways to do this. I mean, this is quite basic scoring. These top-ranking sentences are taken from these summaries. The summary sentences are also from those summaries, and the sentences in context are basically the top-ranking sentence and the sentence that comes before it and afterwards. So going back to this, that's your. Back to this, that's your sentence in context. So that's your sentence there. Click here. You see it in context. It's in blue with the sentence before and the sentence after as well. Okay. So every single user interaction was taken as an indication of interest in this case and used as implicit feedback. Okay, so this point I basically made. We had this idea of a path going between things. So you can go from top-ranking sentence to title to summary sentence in context. So that's basically the path you'd follow by going click, hover, click, and that thing appears. Okay. So at each step. Step you've got, some sort of information about what the person's looking for, or what they are interested in. Paths can be of different lengths, so the person does not have to go down the whole path from start to stop. This bit here basically means that they can get to the document from any of these things. So they can click here, each of these, to get to the source document, or they can interact with things next to the sentences or whatever to get to the source information. So paths can be of different lengths. It's basically the point there. Okay, so it's better for fact and homepage searches. It's good for information exploration, and we're doing a special section of the CSEM right now, and Stephen's here. So we're doing that, and that'll be out next April. So I would see this as a way to encourage information exploration in a sense. We have this interface that points a user to candidate next steps. They say, okay, you're here in the information space. Where can you jump to? What is your next port of call? And just some bits about this. So interaction with these interfaces is used as implicit feedback. Interaction with document representations is more focused on doing it with the full text of documents. So you could do stuff like saving, bookmarking, printing, and that tends to deal with the document, like the document full text, and it's hard to know what parts of that document are actually of use. So and yeah, because we use some, because we deal in things like sentences and titles and such like, then we can get a more accurate picture of what information the person's looking for. Okay, so now that we have our, interface, what happens behind the scenes? What are some candidate models? So I'll just go through these very, very fast because, if you've got questions, please ask me. But okay, so we have one model that's a binary voting model. Basically, every single thing a searcher interacts with contains terms that vote. So if a term is there in a document, in a sentence or a title or whatever else, then it gets a vote. If it's not there, it gets no vote. And basically, we take the total number of votes for each term, and the terms with the most votes are used to expand the query. You have one that's based on Jeffrey's rule of conditioning, where you create a term space at the start, and as the person interacts, then you update the likelihood that terms that are of use, and use the terms that have got the highest score. I noticed that Stephen's in the background as well, so I've got this little thing up here, Robertson 1990. I thought I'd better put that in. So we have three candidate models that are based on WPQ, where you have your document model, which is this takes each document, a path model that takes each path, and what we call here an ostensive model. What this looks like very quickly is you've got a path going from start to end here, and you apply a scoring function that looks something like that basically says this information here is of more use than that information there. Okay, so this information, so you're basically assumed to be here time 0, and this is like time minus, or time minus 1. So you basically say that the information that you look at now is of more use to you than the information you looked at, I don't know, 10 seconds ago or something. And we have one more option as well, which is a random model. Okay, so we've got all of these models. Now what happens? Well, I mean, the next step is, part 2, is what do you pick? Okay, so you've got this yeah, sorry.
Sorry, on the first model, the binary model, I didn't quite understand. So is it anything that they've clicked on or hovered over that goes into the binary model? And everything
Yes. Yes, exactly. Sure. Okay, so this is, you've got all of these models, which to pick, right? So what we do here is we use simulations. Okay, so what we want here is we want a way to test every single possible interaction permutation with the interface, because every single possible interaction is going to be used as feedback. So what we want to say is, okay, if we could in some way control these interactions, I mean, how we tend to get interaction information retrieval is we go out and we recruit people to take part in experiments, and they interact, and we log that, and we do some work with it. What you can do is you can use user simulations, which basically let you cover every single possible interaction. They do it in less time than recruiting real people, less cost than recruiting real people, and they basically give you more control. You know, I mean, that's all upside. The downside is that you don't actually get real people's feedback, and there is, I suppose, an issue of is real interaction being simulated. So that's one thing. What we can do is we can use interaction logs from previous user experiments on the same interface to make a better simulation. So you start off with your baseline simulation, and then you augment it with more information. So basically what we do is we have a trick collection, we have some relevant documents. Because we do it this way, we can get some sort of score, which people who do work in information retrieval, you know, appear to love, is to get a score that says this thing's better than that thing. And what this will allow us to do is to have these 6 candidate models. We have the interface. We now have to pick which of the 6 models is going to which of the 6 models we should use on the interface. So here's basically how the whole thing works. For each topic, you get back some documents, you identify the relevant documents, you summarize them, you create paths and such like. So basically what you're doing here, you're trying to make an interaction space. Right, so it's the space of every single possible interaction with an interface, right? So what we're doing here is we're wanting to construct, in this part down here, I'm just going to skip back a few slides, just a second. So we're actually wanting to construct the interaction space for this interface. You know, so going here and going to the documents, one interaction. Going here and here, that's a different interaction. Going 3 steps is a different interaction. You know, so we want to try to build up a space of every single possible interactions that a person can do with an interface, and then use that to pick the best model. So that's what happens down here. Here we basically make that space. Out of that space, we choose 20 paths at random. You can do this in lots of different ways. Here we chose this way because it's the most straightforward. So you pick 20 random paths, and you wait that you use each path as a source of feedback. you weight the terms, you pick the top ranked ones, you get new documents, and you compute scores.
Ryan?
Yes?
When you say identify relevant documents,
Mm-hmm.
you use the relevance judgment?
Yes.
But you're only working with known relevant documents?
Yes.
How realistic is that? So, I mean, part of the goal is
Yeah,
to
it's-
distinguish relevant and
Yep.
relevant.
We picked that to basically ensure some topical coherence in the information that people look at. We have did work that I'm going to speak about in a couple of slides' time where we don't just do the relevant ones. Okay, so we have the paths there that you pick. And across those paths, here's how each of the 6 approaches perform. So you have the random down here, that's our baseline. You have the 3 WPQ models here. You have the binary voting model here. And you have the Jeffreys one that performs best. Right? Now, there is actually a point up till maybe 3 or 4 paths that this model here, the binary voting model, performs better than the Jeffreys one. So I had thought about doing, this thing here for the first few paths, and then this thing here for the rest of time. But to make things straightforward, I just picked one, and I picked the one that had the best score at the end here.
Question.
Sure.
So I don't understand something again. You're basically getting 20 bits of information from the user, but your precision isn't going up. I would think that would be super valuable information. How come the precision doesn't go up to much, much higher?
I'm not actually sure. I mean, it jumps here. It jumps at the start, like by a lot. I mean, if you look at the differences here in the first few steps, I think it is that this information here doesn't really add new insight, over this information here. So you start off with your baseline, you do some interaction, you get up to here, and then because all of these paths are basically coming from the same documents, then you don't really get any new information.
What is your ceiling of forms? The precision of one, or what's the best you possibly do with this?
The best I have, the best you could possibly do is 1. Yeah, but I mean the best that we've done here is 0.31 something at the end. So yeah, it's quite low. But I didn't do this, to get good scores here. I did this to get this rank order here. So in a way, I didn't really care what these scores were. I cared if this model did better than this model, or if this one did better than, So I was interested in getting to this outcome. So that's the model that we picked. Now you can have something that I refer to. Sorry.
Sorry, can you go back 2 slides?
Sure. 2 slides. Okay.
The create and store all potential relevance paths, were these like weighted at all, or you just every single path that went through relevant? I mean,
every single path had the same chance of being picked. Yeah.
Okay.
I mean, you could do stuff like say, well, just those paths that are more than 4 steps, or if a path's more than 4 steps long, it's got a higher chance of being selected, or you could do lots of stuff. But this was, a first cut. This was, the first time that that this stuff had been done. So it's not. I mean, it was just a.
My question actually is, okay, so this seems very kind of circular, where you're simulating a user, and then you're using that to pick the model that
Yes.
will best predict what the user you simulated actually wanted. And so it seems like by varying the way you simulate the user, basically it seems like you're going to end up picking the model that best matches whatever the simulation was. Right?
Yes.
And so it could be that very small variations in the simulation could have a huge effect on which model does best.
Mm-hmm.
So did you try just like a couple variations just to see if maybe Jeffreys would always come out on top, but
Yes, we tried it. I mean, here we pick the 20 paths completely at random. We tried an approach where we picked each path based on the paths that came before. So say a person was interested in information like what they had looked at before, or information that was distinct from what they had looked at before, and basically the same ranking came out. Yeah, I mean there tended to be small differences in the WPQ rankings. They would change a bit. It means you would occasionally get this one, they're still doing better than the documenter, but these two are always top. Jeffries was always better than the binary.
But it's not a major, huge difference, right?
It's not, exactly, yeah. I mean, basically what this gave me is a way to make a choice. I mean, I had my own opinion about what I wanted to use. So I thought beforehand, perhaps the Jeffries would be a good one, but I used the output of the user simulations, to help me make that choice. So it's not as if I just said, okay, great, there's a gap there, I'll pick that. I had my own feelings about it as well. I better press on now. I don't want to. Okay, so we now have this wandering behavior. Up until now, we've basically assumed all information comes from relevant documents. You can also have some wandering behavior where we assume that people don't always make the right choices. They don't always look at information from relevant documents. Perhaps they'll look at non-relevant as well. So we had this setup where it was between no information was from non-relevant and half of the information was from non-relevant, and basically the same ranking came out at the end. So what this gave us was a tool, in a sense, to pick an implicit feedback model from lots of different alternatives. That tool's not perfect, but it did give us a way that we could make some choice based on how we felt, and also based on how the models performed as well. Okay, so you've picked your interface, your major interface, you've picked your model, then what happens? So you want to think about how should implicit feedback support be offered. To do this, I've got to talk about something that I touched on at the start. There's an idea that I had of information need change. So obviously, as a person searches, their need can change. They can go from one topic to another topic. They can become more sure of the information they're looking for. What we have is, at each point in time, we have a ranked list of terms. Right? So each term has got a score, and we have a ranked list of terms based on those scores. So if you imagine this being at time point 0, this being at time point 1. What we did as a bit of a hack, just to see how well it would work, was you have this ranking here, you compare it against this ranking here with a Spearman correlation coefficient, and you use the output of the coefficient to predict the extent of the change. Okay? So if the need has changed a lot, so basically if this ranking here is different from this ranking here, then you would get a Spearman that would be somewhere down here. Okay? If these two lists are not that different, you would get Spearmans that appear up here. So then the question we have to ask is, what do we do? Well, if it's a big change, it's perhaps a good idea to do a new search. So these are actions that we're going to perform on behalf of the searcher. Okay? So if there's a big change, then perhaps it's a good idea to do a new search. If there's not a big change, then perhaps you want to do something like reordering the documents or reordering sentences. So perhaps if the need has not shifted a lot, then perhaps you don't have to do a new search. This idea that we have right now with web search is, the only option a person has is to do a new search. They can enter words into that box and, do a new search. How about we give them more than just that, more than just a new search, which would perhaps be appropriate for these changes. But for smaller need changes, perhaps you just need information space to be restructured a bit, reorganized a bit. So perhaps a new search isn't the most appropriate thing in all circumstances. So what I have here is the two possibles are reorder documents or reorder top-ranking sentences. So this would be you keep the same document set, but you do a new ordering on that set. This would be you keep the same top-ranking sentence set, but you do a new ordering on that set. Okay, so that's just one thing that I had to do, that I had to talk about before I come on to the next stuff. Okay, so basically what we're wanting to talk about here is how much help do users want at the interface. So we have three interfaces, a manual one, an assisted one, an automatic one. The manual one basically has checkboxes next to every single thing on the interface. They say that's good, that's good, that's good, that's good. These two interfaces do not. And query construction, in this one, the searcher has complete control. In this one, this system has complete control. And in this one, it's shared. And it's the same here as well. So this thing here, execution, is what happens after they've made their new query. Do they do a new search? Do they reorder? Do they do nothing at all? So just to jump straight into the findings here. People tended to want the information retrieval system to infer what information was of use. They didn't want to have to give indications of this thing's relevant, that thing's relevant. I got quite a nice quote out here from one of those that took part. Checking boxes added a new dimension to search that could become frustrating. So people tended to want the interface to infer what information was of use. That's the first finding. Second finding is they wanted to retain control over the new query. So they were quite happy for the interface to make that for them as long as they had the final say about what terms were in that query. I'll just skip past those last points because they're not really of much use. The third finding is they also wanted to retain control over how the new query was used. So they wanted that control, but what was actually interesting is that they tended to want to retain control over choices that had a big impact. So if you're going to go and do a new search, then a user would want control over that. If you're going to restructure information, then they didn't want control over that. They wanted that to be taken care of by the interface. So I'll just say that down here as well. They wanted to experiment with low impact choices. Okay, so the outcome of this was that they wanted to retain control over the aspects of their interaction that they thought were important. They thought, marking checkboxes to say this information is of use was, an operational thing that they would do to obtain assistance but not important. And they saw it as being important to the information retrieval system, not to them. Techniques such as implicit feedback can help address this. Okay, so this brings me to the end of this part of the talk, which is basically what I did in parts of my PhD at least. What I want to do now, and I'll jump through it quite fast because it is 11:30. I promised to be done by 11:30, so apologies for dragging on a little bit. Okay, so if you want some information, I've had a lot of papers published and whatever else, so you can go to those conferences if you're interested. And okay, so that's past, basically. How about what I'm doing now? So I've got on each of these things, I've got a maximum of 2 slides. Okay, I just wanted to give you some insight into what I'm doing now. I don't want to bore you to tears with what I'm doing. I just want to give you a bit of insight. So 3 things are positive and negative feedback using eye tracking, using user simulations to redesign an interface. It's not just pick a model to pick how an interface should look, and story building for relevance feedback. So I'll talk about each of these very quickly. I would see in about 5 or 10 years' time, eye trackers becoming as cheap as webcams. Okay, so you can have an eye tracker on every single desktop, right? So if you can have an eye tracker, what do eye trackers let you do? Well, they basically let you, they give you information about where in a document a person looks and where they do not look. So what you can do is you can infer their interests from the parts that they focus on, and you can build some sort of user model from that. But perhaps more interesting is you can use eye tracking as a way to get access to the information that they don't look at, the parts of the documents that they don't see. So you say, okay, they looked at this paragraph, this one, but they skipped the one in between. So because you have access to that type of information, you can then point the person doing the searching to information in the paragraph they skipped. So you point them into information that they missed and say, hey, what about this? You looked at this paragraph and you skipped straight past this one, but you know the one that you skipped might contain interesting information. So that's what I'm doing right now. We've got an eye tracker and it's all hooked up and it's quite cool. I want to use, in fact I have used users simulations to make new interfaces. So in this talk so far I've talked about using simulations to pick the best implicit feedback model. What I also want to do is say, well, what if the implicit feedback model could talk? What would it say, right? What would it, how would it want an interface to look? Because basically what we're saying here is every single possible interaction is being used as an indication of interest. So how would an implicit feedback model want that interaction to be set up and structured to let it perform the best? So I did some work on this, and this is basically the outcome. So we start off, this is the interface I talked about this morning. We have the sentences and the titles and the summaries. And that turns out to be a good interface. This turns out to be a good interface from the person's perspective, whereas this is a good interface from the model's perspective. So if it could make the ideal interface for it, this is what it would look like. So you wouldn't have top ranking sentences down here. You would have document summaries down here. You wouldn't have long paths that are 5 steps long. You would have short paths that are 3 steps long. You would not have this jump between the sentence and context. You would get access straight to the sentence and context. So what I want to do now is I want to build this interface, and I want to compare it back to this and say, well, this is the interface that people liked. This is the interface that the model likes. So, what's the best? Okay, so that's the second one. The third one is story building for feedback. I'm actually, as part of my postdoc, I'm involved in this project with IBM, UMD, the Shoah Foundation, Johns Hopkins, and a few more teams as well, where we have access to a lot of interviews from people that lived through the Holocaust. In these interviews, they contain a lot of people, places, dates, organizations, this type of information. What I'm doing is I'm working on techniques to help people based on, so they do a search, they want to compose some sort of story. So they start off with some documents and they want to build a story from those documents. So what I have here is I have an interface so far, or how it looks so far. So we basically have 2 parts to the interface. You have the search part that I've obscured a little bit up here, and you have the store and use part down here. So what happens is you do a search up here, you get back some information, and you then take information that you think's cool and of use to you from up here, and you take the mouse pointer, you drag it down, you drop it into this 2D space. Okay, and you put things into this space. In this case, you put in a person or 2 people here. You can then link these in some way. Say, okay, this person was born in that place. This person has been to that place or whatever. You can add notes to this information. And then what's perhaps the cool part, well, I mean, it's all cool, but this is perhaps the most cool part, is you can, based on the information you've stored here, or parts of the information you've stored, you can use that to make a new search. So you can say, okay, I've built this concept map here. Get me information that's just like that. Get me information like this. So, I want information. I want people that are just like this person, or I want people that are like this person and have also been to this place. So, it's a way that we can help people, construct a concept map to structure their thoughts, and then use the concept map to do a new search. Use their picture of their information need, if you like, to do a new search. So as I just say here, 2D space, you put in these things here, these fragments, and then you use information you've stored to drive a new search. And last slide. So some more ideas for the future. What I want to do is explore context as well in implicit feedback. So I want to look at things like task. Can you automatically detect task and other contexts that affect it? Can we do some more work in information need change? What I did so far was just a bit of a hack about, you have these 2 ranked lists. Are they the same or are they different? Can we do some more work there? What I tended to find just on this third point here was that if you were to draw a plot of how much implicit feedback was used during a search, it would look a bit like that. So you'd have this point at the start where it's not really used, and you'd have this point at the end where it's not really used. And then if you put over the top of that, so that's implicit feedback. Implicit feedback. If you put over the top of that a plot of when explicit is used, it looks something like this. Okay, so this is explicit. So people would tend to use explicit here at the end of their search. They'd get to the end and start to panic a bit and think, well, what do these checkboxes do? They'd be like, oh yeah, let's try this and see what happens. So they would get to the end of their search and they would give this feedback, and they wouldn't really tend to give this sort at all at the start or at all at the end here. So what I mean by that third point, where I talk about implicit, explicit hybrid systems, is there a way in which we can combine, so use implicit feedback up until, say, this point or something, and then after that also use explicit, or some way to to make use of the two. I want to make groups of user simulations. So you could perhaps have an experience block of simulations, an inexperience block of simulations. People that interact in a certain way, people that don't go past page 1 of the results, people that jump the first 10 pages of the results. So I want to make different groups of user simulations, try them out. And I also want to improve the quality of the simulations with logs from search engines as well, to hopefully make them a bit more real. And that's me. Thank you very much for your time, everyone. I think that's it. Yeah.
If you had the search engine logs, would you still need the simulations?
Yes, I think you would. I mean, you would take from them, you would use them to build up some sort of a user model. So you'd perhaps have a different user model for each searcher, if you like, and then you could use it, not just, so, like, it's quite a tough question, actually. You would then, see, it's not about using them with the data you have, it's about what you can do with them with new data. So you would use the logs to make your simulations, but then you would apply them in a new context. So the logs would give you the basis for making your choices in your simulations, but they wouldn't be the things you would work with eventually. I don't know if that makes sense. It's an excellent question, really is. Never thought it. Any more?
Yeah.
Yep.
So you started by assuming a more complex user interface and interaction model. But I don't know if you were trying to justify through that here, but did you look at doing the same kind of modeling with a more traditional?
Oh yeah, exactly. That's what I would. That's what I would like to do. I would like to use this data here from the search engine logs, and then do it with a standard ranked document list type interface, and see if it holds true there. I mean, what the techniques I've talked about this morning allow you to do is to, okay, you've got this interface which can be a ranked list of documents. How do you pick the implicit feedback model to go behind that. You know, so you've got 10 different alternatives. Which one do you pick? You know, so basically what the approach here assumes is that every single interaction is an indication of interest. You know, so building a simulation in that appears to make sense to me.
To follow up on Robert's question, so
Yep.
you showed these curves, these simulation curves that rank ordered your different techniques for
Yeah.
selecting the keywords. Did you ever compare that with what you get from either pseudo-relevance feedback or explicit relevance feedback? So, you know, imagine that you could coerce the user into telling you that
Yeah.
2 relevant documents, or
Mhm.
imagine that you assume the first K are relevant.
Yep.
What do those curves look like? Do you get larger improvements by doing
I didn't do that work. I didn't do that, no.
So one of the things that you were talking about, stuff that you're sort of playing with now, is the eye tracking work. And
Yeah.
you said that you were using that for implicit feedback information. One thing I'm wondering about is, one thing that's known with gaze tracking is that small changes in display and how you arrange items, things like that, can make enormous differences in where people look and what they look at, et cetera. So are you more focused, I mean, some of the things that you were talking about being interested in are, say, paragraphs or context of what you're reading over.
Yeah.
Are you looking at entire pages? Are you looking at results presentations? Are you looking at all of the above? What kinds of things are you playing with? Because
yeah, we're playing with structured documents. So it's documents that have section headings. So what you would do is you would look at, you know, a person would look at a section heading and then skip it. So that's an indication that they're perhaps not interested in that section. Yeah, these are
what kind
government reports. It would just be basic question answering tasks. So they would get their task would be to gather information about something or to find a factoid or something like that.
Thank you.
Thanks.